Hello, hi guys, how are you? Am I audible as well as visible? Sorry, I'm a bit late than the scheduled time. I'm just 4 minutes late, in fact, right? Am I audible as well as visible, guys? Just a second, let me open your chat. Let me open your chat. Yes, I think I'm visible. Perfect. Okay. Am I visible, guys? Please, can you tell me? Can you just confirm yes on the chat? Can you just confirm yes on the chat? Can you just confirm yes on the chat? Yes, perfect. So I can see Ronit, Yash, Kumar Rakshit, etc. So in today's lecture, we'll be covering factors and multiples, right? Factors and multiple, and this is like one of the last lectures. I may take one more lecture of number theory, but the next two lectures, if I do not take any more lectures of number theory, then the next two lectures will be devoted to solving the IOQM PYQs of number theory, so that we complete the chapter with respect to number theory. In fact, see, like, number theory is one such chapter which has interface in all the other chapters. So if I talk about combinatorics, which is going to be the next chapter, in combinatorics we'll be covering more of number theory, but the core principles of number theory are over, right? 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 So let's complete this thing. So this is our JEE advanced result, guys. 18 ranks in top 100, 787 ranks in top 5,000, 2200 ranks in top 15,000, 4129 plus selections in JEE Advanced 2025. It's such a huge number, right? And this was JEE main results. This was JEE main results, right? So if you want to study from me in an academy, in JEE subscription, you can use the code PJ Live. You know it. All the links are in description. Okay. And if you want to study for IOQM, then go for the Olympiad Gold. Right? And we have the target of getting 1,000 selections in IOQM from an academy platform this year. And IOQM English is a step in that direction. Okay. Yes, I'll teach combinatorics. The combinatorics will be taught by me. That is what I have decided. That is what I have thought. Although I am taking help of other educators, I am taking help from Ayush Patni sir, who will be teaching you sequence and series. Like he will be starting his lectures in English from Monday. And geometry, I have already taken help from SPS sir. All the educators with whom I am taking help are senior educators of an academy. My aim is that I should not be the bottleneck in your preparation. See, like if I'm not getting the time to teach you all due to many other priorities that I have, you should not suffer. That is my whole aim. Okay. Okay. So should we start? So like, see, like, first of all, let us understand what are divisors as such, right? Divisors, what do I mean by divisors? And we'll follow certain nomenclatures here. If I talk about 6, right, 1, 2, 3 and 6, these are divisors of, basically these are positive divisors, right? Positive divisors of 6, right? Positive divisors. Okay. Usually in number theory, when our majority of the focus is on positive integers, that is natural numbers, usually we change these two things like factors and divisors interchangeable. Although when we talk about factors, it is positive divisors only, and when we talk about divisors, it is positive and negative both. Why we study negative integers, negative divisors, I'll let you know. But all the definitions, for example, the definition of prime number, a prime number has 2 divisors, right? When we are saying that prime number has 2 divisors, we mean positive divisors only, right? 1 and itself. So divisors are, unless otherwise mentioned, will be assumed to be positive. Okay, these three are proper divisors. Proper divisors. Proper divisors of 1, 2, 3. These are proper divisors of 6. Basically, all the divisors which are less than the number are called proper divisors. Okay. 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 please write DN if you have understood the definition of proper divisors and total divisors, right? And we will use the help of combinatorics to actually find the number of divisors. Actually, this topic I was thinking to complete this topic in combinatorics, but then I thought otherwise. Let's do it in number theory and then we'll revise it in combinatorics, right? That is what I decided now. So when I say 6, right, let's use fundamental theorem of algebra, in fact arithmetic, to factorize it. It is 2 to the power 1 into 3 to the power 1, right? So if I am taking any divisor of 6, it will be of the type 2 to the power p and 3 to the power q, right? Where p can be 0 or 1 and q can be 0 or 1, right? Am I making sense, guys? Am I making sense? All the divisors D of 6 will be of the form 2 to the power p, 3 to the power q. 5 cannot magically appear in it, right? Because when 5 is not present in the original number, how can its divisor have 5 in it? Okay, and the power should be less because D divides the 6. All the divisors, that is why they are called divisors. Divisors divide the number, right? So these powers cannot be more than 1. Okay, and that is how we calculate the number of divisors. If I talk about dn is, if I represent dn as number of divisors of n, then dn is, see, I can select p in 2 ways and I can select q in 2 ways. So 4 divisors. That is how it is to be calculated. How it is coming? Let me illustrate. When p is 0, q is 0, my divisor is 1. When p is 1, q is 0, my divisor is 2. When p is 0, q is 1, my divisor is 3. When p is 1, q is 1, my divisor is 6. All the 4 divisors are listed here. If you see, for every p, I can choose 2q, and that is why for 2 p's, 2 into 2 is the total number of combinations, and that is how we arrive at the formula of number of divisors. The next step is to generalize it. But first of all, did you get this thing? How am I calculating the number of divisors? If you are clear about it, just write UDAN, understood, done and noted. If you have noted it down in your copies, just write UDAN, understood, done and noted. Sir, I am seeing you first time live. I hope I look more beautiful in live than recording. Right? Sir, is extra theory needed for RMO questions or just applications of IUQM levels? So you see, like in RMO workshop, which we are going to conduct very, very soon, there will not be any new theory. There are certain proving techniques which we will teach, definitely. Inequalities is something which we will teach, but largely we are covering the theory at the level of RMO only. Okay? Okay? Perfect. So now let's generalize it. Generalization of this formula. If I generalize it, let n be prime number 1 to the power a1, prime number 2 to the power a2, prime number 3 to the power a3, and so on. Then number of divisors of n, you just simply have to add 1 to it. Why? Let me just tell you why. Right? See, if I take any divisor, my prime number p1 can take power, if this is if this is the representation of any divisor of n, then my b1 can take 0, 1, 2 till a1. So how many values are these? These are a1 plus 1 values. That is why I have written a1 plus 1 here, a2 plus 1 here, a3 plus 1 here. If somebody is asking me number of proper divisors, no problem, no problem. The answer will be dn minus 1. Okay, because the number itself is to be subtracted from it. Okay, okay, so this is elementary counting technique that you have taught. Yes. Okay, got it? So this is the number of proper divisors dn minus 1. Now let's take a great look on this formula. Let's apply it, right? If I talk about any random number, can you find dn for me? What is dn? For 1764. 1764 is a very beautiful number. It is 42 square. Let us find the total number of divisors. Can you write it in the chat? Can you just write it in the chat? Just write it in the chat. What is number of divisor for 1764? The step 1 is very simple. You have to apply fundamental theorem of arithmetic. When you apply fundamental theorem of arithmetic, then the dn becomes 2 to the power 2, 3 to the power 2, 7 to the power 2. Right? And then, sorry, this is n actually. This is n, not dn. So then dn becomes 2 plus 1, 2 plus 1, 2 plus 1. That is 27. Now, can you observe one fact above? Can you observe one fact here? It's a very important fact. Only perfect squares can have odd number of right? P1 to the power A1, P2 to the power A2, P3 to the power A3. Now, if I look at the formula A1 plus 1, A2 plus 1, A3 plus 1, dot, 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 I am already seeing here that if this is even, I add 1, this becomes odd. For this to be odd, all the numbers have to be odd, which means all AIs should be even. All AIs should be even. And hence this point, only perfect squares can have odd number of divisors. Right? 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 So cutoff for 11 this year IOQM. See, like all these things we will cover after I have done this. After I have we have the notifications. After the notification, we'll do all these type of videos. That what should be your target score, what are the cutoffs, right? Okay. Okay. For now, you should focus on learning. Like just focus on learning. Okay. Now let's write down. Let's write down all the divisors of 1764. There is a process of writing it. When you are enlisting the divisors, you should do it in a pattern, right? If you're writing 1 here, just write 1764 here, so that the product is 1764. If you're writing 2 here, simply write 882 here. If you're writing 3 here, then what comes, like just divided by 3, it will be 5, 8, 8, okay, 588, 244, oh, 294, 197, no, it will not be 288, it will be 288, right, 288, it will be 288, it will be 588 only, right? Have yes, I think I have evaluated it correctly. 299, no, 294, and then 294 divided by 2 is 147, yes, correct. Then 4, when I am dividing it by 4, it should be a perfect square of 21, this becomes 441. Are you understanding the pattern? These things are called divisor pairs. These things are called divisor pairs, right? This is a divisor pair, this is a divisor pair, this is a divisor pair. So if I continue, keep on continuing, if I keep on doing it like this and write it like this, then I will have this D1 D27 equals D2 D26 equals D14 square. D14 is actually nothing but 42 equals 1764, right? If I am listing the divisors like this, and there comes one important point. If DI DJ is a divisor pair, and DI is less than DJ, then DI will be less than square root of n, and DJ will be greater than square root of n. Very important point, right? Because that is how you multiply them and get n, right? Just see this, you are multiplying these two and getting n. So one number has to be less than root n, that is 42, and one number has to be greater than root n, that is again 42. This number is greater than 42, this number is less than 42. So in this row, every number will be less than 42 except obviously the last one. This is something which is different about it. And in this list, in this column, you have every number greater than 42 except this number. Are you getting my point? This is a very important highlight. On this thing, we had a question in IOQM 2024. And this question was covered in my book. I had made a video of it, that the questions are coming directly from the book. But to be very honest, this question came in AIME, American Invitational Mathematics Examination. Okay. Right? There is your IOQM series available now on YouTube. My IOQM, see, like my IOQM is available everywhere, right? My IOQM is available in English and as well as in Hindi. Okay, please show the question again. The question, see, like we were just listing and we have just written the property. Another property is 1 divides every number, n divides every number, n divides itself, 1 divides itself. One is identity with respect to number of divisors. All these things are there. Okay. So I think we should definitely do a problem here so that all of us can understand how we have to calculate the divisors. Should we do some problems based on it? I think we should. Now, question number 1. Find all two-digit numbers which have 4 divisors. This is a IOQM PYQ. This I think came in 2022 or 2023. I'm not sure about the year, but this question came. And this question is inspired from KVPY examination, which used to be a very standard examination. बताइए. 30. Got it. So, see, like, now there is an algorithm to this problem. Obviously, this is something which is hit and try. But again, this is a directed hit and try. So, first of all, you have to understand that the n will be of the form P1, P2 or P1 cube. This is the first step. Because in this case, if it is a product of two prime numbers, then the number of divisors are 4, or P1 cube, which means the number of divisors are 4. Now, if I take case 1, which is simpler, which is if n is of the type prime number to the power 3, this gives me 8, 27. Prime number cube. We need prime number cube. Don't write 64 here. 64 is a silly error because 64 is actually 2 to the power 6, which has 7 divisors. Right? You have to make sure that you are writing cubes of prime numbers only. Now, this is rejected since it is not a 2-digit number. This is going to be the only number. So, 27 is your one number. Now, let's talk about the second one. Second case is n is of the type PQ. Again, just see how categorically and how while making the case, I am making sure that there is some logic to it. I am taking P less than Q here, right? And then if I take P to be 5, what are the possible values of Q? Q can be 5 because again it is making it a 2-digit number. Then 7. I'm then just simply writing all the prime numbers 11, 13, 17, 19, and I can clearly see that since the product has to be a 2-digit number, the biggest prime number is 47. Okay, this you have to do mentally. 21, 23, 25, 27, 29, 31, 33, 35, 37, 41, 43, 47. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It is very important that you list it like this. Now, when prime number P is 3, and since I have taken P less than Q, I cannot take the case of Q equal to 2. Obviously, it is anyway rejected since it is a single digit number. Q becomes 5, 7, 11, 13, 17, 19, 23, 29 until 31. Because 31 times 3 is 93. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then P equals 5. Q becomes, again, you cannot take Q equal to 3 here because Q equal to 3 and P like 15. The case of 15 is already covered, right? And like if you do it like this, you will ensure that there is no repetition in the cases. 7, 11, 13, 17, 19, 5. If I take case of P equals 7, Q becomes 11, 13. Right? These are the two cases. That's it, I guess. No more cases. Only these are the cases. So how many are these? 22 and 7, 29. 29 here and 1 here. In total, there are 30 cases. Have you understood the logic here? Have you understood the logic here? 30 is the answer. The PYQ session is next. Okay guys, I hope you have understood this problem. This is a very important problem, and all the learners who are seeing it in recording, if you have understood something and if you like the lecture, please do leave a comment so that I know some of you are seeing this in recording. Also in recording, like all the learners who are live also, this is my message to you all. If you're not understanding anything, just bookmark it. Just mention that this is the question which I am not being able to understand, and then just see the recording later. Okay. Okay. Now, question number 2. Let's see question number 2. Okay. Let n equal 2025 to the power 6. This is a red hot problem this year, right? Find number of divisors of n which have odd number of divisors. Odd number of divisors. Which have odd number of divisors. Which have odd number of divisors. So, strategy for revision. Strategy for revision. We have not completed the syllabus yet and you are asking the strategy for revision. I hope it is not the revision strategy for the final. Power is 6. Power is 6 guys. The power is 6. This is 6. What is IOQM? IOQM is Indian Olympiad Qualifier for Mathematics. It's highly coveted examination. It has huge respect. Now let's solve it. First of all, every time the first step is to write the factorization of this number. What is 2025? If you see 2025, it is 45 square. This means 3 to the power 4 into 5 square. Am I making sense here? So what is n to the power 6? This is 3 to the power 24 and 5 to the power 12. Am I making sense guys? Am I making sense that n is 3 to the power 24, 5 to the power 12? Has everyone got it? And see, then the logic behind this problem is all the divisors which are favorable. Find number of divisors of n which have odd number of divisors. This means my D has to be a perfect square. So my D will be of the type 3 to the power 2p, 5 to the power 2q. And you can clearly see here that my P can take the value 0, 1, 2, 3, till 12. Why I am stopping at 12? Because 2 times 12 is 24, which is the limit for P, which is the limit for the power of 3. Similarly, when I talk about Q, my Q can be simply till 6, right? 0 till 6. So how many ways can I select P? 13. How many ways can I select Q? 7. 13 times 7 is 91. Got it? 13 times 7 is 91. So 91 is the correct answer. 91 is the correct answer. Few of you have written 90. Many learners ignore 1. 1 is also perfect square. Do not ignore 1. Obviously, we should count 1. Why not? Why not count 1? How many divisors does 1 have? 1 itself, right? It is neither composite nor prime. What is the definition of composite numbers? Numbers having more than 2 divisors. What are prime numbers? Which have 2 divisors. So what is neither prime nor composite? 1, because it has only 1 divisor. This is my sincere request to 11th class learners. Do not prepare for IOQM separately. Just give the examination in continuation of your JEE preparation. All you need, simply, what you need is simply number theory and geometry, which you can cover from this channel. Right? Are you getting my point? Are you getting my point? Okay. Right? Sir, IOQM, live problem solving. How do I develop problem solving? See, like IOQM is like, it is a long journey, right? You do not become god of manipulation one day. It's a daily process. Every day you improve this much, right? We had this thing, right? You must have seen this in reels or somewhere, that 1.01 to the power 365 is somewhere equals 37. And 0.99 to the power 365 is like, it becomes negligible. What do I mean by this calculation? If you just put in 1% more effort every day, it compounds to 37 eventually. So 1 times 1 times 1 times 1 times 1. If you are putting 100% effort every day, 1 into 1 into 1 into 1 eventually becomes 1 only, right? Howsoever times you multiply 1, you will get the answer 1. But if you are multiplying 1.01 365 times, you are getting almost 37. This is the power of compounding. You improve every day. You will not get results in 1 week, you will not get results in 1 month, but in full year you will get results. And it's a long-term game. You are going to get results in the long run, right? You must have seen interview of Muhammad Anas, who got All India rank 42 this year. He studied for IOQM in class 9th and 10th, right? He did not get great RMO selection or INMO selection, but he was able to develop the manipulation, and he got 102 marks in mathematics. Mathematics question paper was very difficult this year in JEE Advanced. Still, he was able to get 102 out of 120, which was very instrumental for him in getting a rank like 42. 42 is a great rank. Okay. Okay. Yes, this is Atomic Habits. Very good. I am taking it from Atomic Habits. It's a very nice read. It's a very good book. Yeah, we'll launch a batch from basics. We'll definitely launch a batch from basics, right? Okay, We will launch a batch from basics. Don't worry about it. Right? Let's do another problem. Find number of divisors of 2025 to the power 6 which are less than 2025 to the power 3 but do not divide 2025 to the power 3. Okay. Okay. Yes, we will launch a new batch very soon. Okay. Just solve this one. Okay. Am I clear, guys? Tell us. Find the number of divisors . 42. No. So see, this problem is very simple. My n square, I will call it n square, right? I will call it n square is 22 5 to the power 6 and this becomes 3 to the power 24 5 to the power 12. My n is 25 to the power 3 which is actually 3 to the power 12 5 to the power 6. So the question is very simple. Find number of divisors of n square which are less than n but does not divide n, right? So my algorithm is very simple. I will calculate the number of divisors of n square, right? It becomes 25 times 13, that is 13 5s are 65, 13 2s are 325. Okay, what are the number of divisors of n? 13 times 7 is 91, right? If you see, in these 325 numbers, right, in these 325 numbers, 162 are less than n, 162 are greater than n, and 1 is actually equal to n. Okay, are you seeing this properly? And out of these 162 numbers, in this 90 are less than n and 1 is equal to n. So can I say that out of these 162 numbers, 90 divides n? So if I subtract this 90 from here, I will get 72, which is equal to the number of divisors, 72 are the number of divisors which are divisors of n square less than n but do not divide n, because 90 of these, see, like all 90 are counted here also, because it's very simple. If A divides B, B divides C, it implies A divides C. So if A is divisor of B, B is divisor of C, then A is divisor of C. Okay, so all these 90 numbers are counted in these 162. Out of these 162, these 90 are dividing n, which means 72 are the numbers which do not divide n. And this is the answer. This is the answer. Okay. Okay. Not 71 is not the answer. Right? 72 is not the answer. 72 is the answer, 71 is not the answer. Am I making sense here, guys? Am I making sense? Am I making sense here? So this is where some of the alphanumeric problems also come. This is where some of the alphanumeric problems also come. Right? Find number of numbers of the form AB, 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 which have just a second, which have 32 divisors. Very interesting problem. Very interesting problem. Which have 32 divisors. This becomes a very interesting problem, right? A is not equal to 0 here. So this means that it is a 6-digit number. It's a 6-digit number. It is a 5 marker, guys. If you do it, it is a 5 marker. It is a 5 marker. Okay. It is a 5 marker. What if n itself is a perfect square? That you have to see. बताओ दोस्तों. Batao. Have you get the answer? Have you got the answer? 5. 5. Now it's a very interesting thing. First of all, let us analyze this number. This is AB, AB, AB. This means AB times 10101. Right? Now if I factorize 10101, I will get 3 times, 7 times, 13 times 37. Have you got it till now? Have you got it till here? Have you got it till here? Have you got it till here? Now, obviously, I already have 4 divisors. I already have 4 prime numbers as product. So, I have 2 cases now. If my n becomes 3 times 7 times 13 times 37 times a prime number, which is obviously not equal to any 4 of them, I will get dn equals 32. But P has to be a 2-digit prime number. A 2-digit prime number greater than 10 and not equal to 13 or 37. Okay. Now this is where it helps that we have 25 prime numbers in top 100. So out of these 25, I am subtracting 4, which are essentially single digit numbers. So I have 21 2-digit prime numbers. Then I am subtracting 13 and 37. So in this case, I am getting 19. In this case, so see, like this was PJ exclusive. This is the question which I have given for the first time. And I can clearly see that many of you are not getting the right answers. All the previous ones in which you were getting the answer were either PYQs or old problems. This is a new problem. And I could not get answer from any one of you in the basically the given time. Right? Why not 5? See, like this prime number cannot be 5. This prime number cannot be 5. If this is 5, your number becomes 50505. And I have written A is not equal to 0, which means it is a 6-digit number. It has to be a 6-digit number. Okay. Then my another case is if somehow I get power 3 somewhere. If I get power 3 here maybe, then this becomes 27 times 10101. Right? This is 272727. And this is 3 to the power 3, 7 to the power 1, 13 to the power 1, 37 to the power 1, which essentially has 32 divisors. 4 times 2 times 2 times 2. This is the case which is usually missed in this problem. Okay. Okay. Just see, like, Garg, solve it, no? 50, 50, 50. How many divisors does it have? Solve it. If you are claiming any answer, check for yourself, na, how many divisors does it have? 50, 50, 50 does not have the required number of divisors. Okay. So, you needed 32 divisors. This is the problem. You cannot change the nature of the problem. Sir, how can we practice the lessons taught in this course at home? Aditya, very simple. You have to solve my book. My book is available on Flipkart, Amazon, everywhere. You just can buy it, and the solutions are also written at the end. Are you getting my point? These are the two things. So in total, you have 20 cases. If you try to make this 3 to the power 1, 7 cube, I think 7 cube will also work. 7 cube will also work. It is 21. 7 cube will also work because it will be 3 into 7 into 13 into 37 into 7 square. 7 square is still 49, which means 49494949 will give me the correct answer. In fact, this is 9. 3 cube. Oh, I got it. In fact, I have made a mistake here. 3 cube will not work. 3 cube will not work because 3 cube will give me 90909. Okay, because 1 3 is already counted here. I was counting 3 here also and here also, which was my mistake. So only this number 494949 will be acceptable, because this is 3 to the power 1, 7 cube, and 13 to the power 1 and 17 to the 37 to the power 1, and it will give me 32 divisors. So the answer remains 20. It is like we got it correct by luck. We got it correct by luck. Right? The only case of this type will have power 3 above 7. 7 can have power 3, nothing else. Because 13 square is 169, 37 square is 1369. Okay. Wish it happens in IOQM. Yeah, we'll have to see. I don't think it will happen. Right? Got it. Perfect. Let's move on. Why you removed KVPI problems from your book? I think it was a mistake. I will again reintroduce them. Why did you subtract? Sir, I subtracted 2 because this 2 represents these two prime numbers, 13 and 37. Okay. Getting my point? Okay. Question. Now another question. Let's do another problem. Okay. Find number of two-digit numbers with dn equals 8 and dn is equal to twice of dn. dn is number of divisors, right? Number of divisors. Okay. 8. What is dn? Dn is written here. Dn is equal to twice of dn. This question is very simple. This question is very simple. Basically, you have to calculate dn equals 4. You have to find all n such that dn is 4. Right? So the answer has to be 30. We have already calculated this number. We have already solved this number. Right? We have already solved it. Right? dn is twice of dn, which means, and dn is number of divisors. So all you had to do, I have just put an extra layer. Right? So if this was mac veggie, this is mac veggie with cheese. Nothing more than that, right? It is not a new problem. And still learners got confused. So in many of the problems that you face in IOQM, you will face a language problem as well. What is dn definition? It is written number of 2-digit number with dn equals 8 and dn equals this. Oh, I got your point. Where I should have written where dn is this. Where dn is this. Right? This was the meaning of the problem. It will be very clear in IOQM. When it comes in IOQM, it will be very clear. I got your point. I got your point. I did not write it properly. Okay. Now, sum of all divisors. Sum of all divisors. Right? Sum of all divisors. Right? So, first of all, I am going to write a formula here. If I am going to write a formula here. Right? 1 plus r square, r to the power p minus 1. If this is s, right, multiply by r and write it like this, right? And I'm just shifting r to the power p. See, like if I multiply r here, every term will get multiplied by r. So this 1 becomes r becomes r square becomes r cube, and r to the power p minus 2 becomes r to the power p minus 1, and r to the power p minus 1 becomes r to the power p. If I'm subtracting it, I get r to the power p minus 1. This everything will get cancelled. R minus 1 into s. So my s becomes r to the power p minus 1 upon r minus 1. Right? 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 Are you getting it? Are you understanding this sum? This type of progression in which every number is getting multiplied by a constant to get the next number, this type of progression is called geometric progression. Right? You will study this in Ayush Patni Sir's lecture. Ayush Patni Sir's lecture, you'll understand this. So this is sum of GP. Right? So now just see, let me illustrate, let me explain you the sum of divisors. If I call sum of divisors as Sn, right, let's take the case of 6, right, divisors of 6 are 1, 2, 3, 6. So I have to add all of them. Now, can you see that I can write it like this? Can you see it? Can you see it? Right? And if you see properly, it is 2 to the power 0 plus 2 to the power 1, 3 to the power 0 plus 3 to the power 1. And it is not a coincidence that it is coming like this. It is coming like this. See, every term of this product, 2 to the power 0 into 3 to the power 0, 2 to the power 0 into 3 to the power 1, 2 to the power 1 into 3 to the power 0, 2 to the power 1 into 3 to the power 1. All these terms are actually divisors. So basically, if I generalize it for this number, 1 plus p1 square, p1 to the power a1, 1 plus p2 plus p2 to the power a2, this product will give me the sum of all divisors. This product will give me, and when I apply this formula here. How many terms are here? A1 plus 1. So P1 to the power A1 plus 1 minus 1 upon P1 minus 1 into P2 to the power A2 plus 1 minus 1 upon P2 minus 1. This is the formula for sum of divisors. This is the formula for sum of divisors. Got it? Done. Please write done. Understood, done and noted. Thank you, Garg. 100% हो जाएगा. Gayasuddin is saying, sir, if we do complete of your book, then will we qualify IUQM for sure. Perfect. This is good. This is good. Now question. See, this is the last problem. This is the last problem of the day. Yes. This is the last problem of the day. Actually, we cannot do it now. Find sum of, find all n less than 100 such that S of n equals 2n. Sum of all divisors equals 2n. Right? Right? Got it? You can buy my book from Amazon. It is called IOQM Mathematics. See now, This is a problem related to memorization. See, like, if you see properly, uh, just a sec. If you see properly, yes. So these are called perfect numbers. What are perfect numbers? Perfect numbers are like 6, which are sum of their proper divisors. So if you see 28, 1 plus 2 plus 4 plus 7 plus 14. And there are only 2 numbers which are less than 100, and if you see properly, this becomes 2 to the power 1 into 3 to the power 1. This is 2 to the power 2 into 7 to the power 1. Okay. So usually it is of the form something like, I forgot the form. It is 2 to the power something into another prime number, right? And we can actually solve it. We can actually solve to get it, right? We can actually try to find. So like, this is one of your GBQ. You have to find general. Just write it in the comment section. You have to find the general term, general expression for perfect numbers. What are perfect numbers? Perfect numbers are those which adds up, like, so such that their proper divisors adds up to the number itself. Okay. So the answer will be 2. Okay, guys. So I hope you got it. If you do get it, please do let me know. And after this, you can actually do factors and multiples problem of like section of my book. And from the next week, we are going to do the PYQs of number theory. Let's crack it.